Hello and welcome to today's class. We'll proceed in the study of differentiation. Last class, we look at the first method of differentiation called general method. Yet, we look at the second method called the first principle. If you miss our video or on differentiation, the introduction to differentiation, that is the first method, I'll drop the link to that last class video in the description of this video. So check the description of this video. You see a link to our last class on differentiation, which is said to be the general method. So let's look at second method called the first principle method as being the second method of differentiation. All right. Last class, we emphasized on something when it comes to general method. We said when it comes to general method, the key concept there is that multiply by the power and subtract 1 from the power. Similarly, when it comes to first principle, the concept changes, right? So the key word to note when it comes to first principle is that to y, you are adding change in y, to x, you're adding change in x. So the key word to note when it comes to first principle is that to y had change in y, to x had change in x. Let's do a few problems and let's see how we can possibly evaluate the problem using first principle. All right, let's take example. Let's say I have that y is equal to x. I'm told to differentiate this using first principle. What do you do? Before I use first principle here, let's do a quick recap on general method. Usually, general method is simply a shortcut. Why first principle is like a long procedure, or let me call it a long cut per se, to finding the problems of this. So let's say neutrally, I have that y is equal to x as I have there. I'm applying general method here, right? What do? We said I'm representing y with respect to x. I'm meant to have the y over the x because I'm representing y with respect to x. I'm having this. This is not equal to, we said, multiply by the power. What's the power here? Invisible 1 is there. That becomes 1 times what? This is x to power what? 1 minus 1. If you watch our last class, you should know this, right? From here, I'll have that the y over the x here is equal to 1 times x is what? Of course, x. Raised to power 1 minus 1 is what? It's 0. And we said any variable raised to power 0 is what? Is 1. For me, I have that the y over the x is equal to 1. Applying general method, I have 1. Let's apply first principle and let's see if we're going to have that same 1. All right, for first principle, we said to y add change in y, to x add change in x, as easy as that. I'm saying y, this is y, we said to this y add change in y is equal to, this is x, we said what? Add change in x. All right, change in x. So we're at this point. Proceeding from here, we said to y add change in y, to this x add what? A change in x. When you are done with this, what next? I'll take this y to the other side here. I'll be left with what? Change in y is equal to x plus change in x. Of course, if I take a positive y to the other side, becomes what there? A negative y. So we're here. After taking y to the other side, I have negative y. At this point, I will now say, but this y is equal to what from the question? But this y was x from the question. Y was x from the question, right? So whenever I see y, I'll put x. So I'll have that change in y is equal to what? X plus change in x minus, what is y? Y is x from the question. So that's x. I have this. So look up. From here, I'm having plus x and minus x. Of course, it will cancel out. So plus x and minus x is of course 0. So it's off. From this point, I will have change in y equal to what? Change in x. At this junction, I will divide both sides by change in x. So at this point, divide both sides by change in x. What am I expecting? I'm expecting that I'll have change in y over change in x is equal to what there? Change in x over what there? Change in x. So we said divide both sides by change in x. So I'll divide it by change in x, divide this by change in x. What do you observe? From your math approach, of course, this will cancel this. That's my answer becomes 1. So change in y over change in x. It's the same thing as the y over the x. So note that change in y over change in x is the same thing as what? The y over the x. All right, is now equal to 1 over 1 is what? Is of course 1. So observe that when I use first principle, I have 1. When I still use derive method, I still have 1. This is how to differentiate using first principle method of differentiation. See you in the next class where we're looking at much more problem under first principle before we go to the third method called the chain rule method. So next class we'll look at several more examples on first principle.